Good evening, everyone. Right. So today we're going to start up with something called as bitwise algorithms. Okay. So we're going to start with bitwise algorithms. Okay. So what exactly these bitwise algorithms means? See, there are a lot of problems that can be solved in a most efficient way using bitwise operators. Right. So, what kind of examples, and also we need to understand what is a bitwise algorithm, also, right? So, the reason why we use these bitwise algorithms, right? So, first of all, we need to understand what are the different operators we have: bitwise AND, bitwise OR, bitwise NOT, bitwise XOR, left shift, and right shift. So these are the six bitwise operators which we have, which will help us to solve lot of problems which are based on binary. And even if they are not on binary, some of the examples that can be solved in a more efficient way, right? They can be solved in a more efficient way when it comes to, right, using bitwise operators. Okay, so you need to understand the working of all of these operators, right? So I probably assume that you guys are aware about the behavior of all these operators. Okay, should I, if you want to use bitwise operators, right, to solve problems, you need to understand certain number of, right, problems which are very basic problems, right? The first question is how to set a bit in nth position. Okay, how to set a bit in nth position. For example, let's say I will give you a number is equal to 4, right? And I'll give you a position as 1. Okay, I'll give the position as 1. Okay, now what is the binary of 4? Binary of 4 is represented like this. I'm just assuming 2 byte integer. Okay, this is the binary of 4. So we need to set the bit position number 1 and so on. This is 8, this is 15. These are the bit positions. Now I need to select a particular bit. That position will be given by the user. So whatever is, we don't know what is the bit present in that. Is it 0 or is it 1? Generally, we call 0 as unset or reset bit. Okay, and 1 is called as set bit. Okay, 1 bit is called as, right, set bit. Okay, we need to understand that first. And now I need to, right, set the bit position, right, the bit present at a position 1. I need to set it to 1. I have to make it as 1. So how we can do it? Very basic steps here. Step 1. Okay, right, left shift, left shift 1 by n times, right? So you take the binary of 1, 1 left shift by n. So if you take the binary of 1, it will be like this. Okay. Now if you left shift every bit, if you left shift every bit by 1 time, right, then the result will be, right, this 0 0 1 0. Now you need to perform, right, you need to perform, right, bitwise OR operation. Use bitwise OR to set a bit at nth position. So first step is, right, step 1 is left shift the number, shift 1 by n times. Then step 2, right, then use OR operator, then use OR operator to set the bit, right? So how do we do that, right? So now num is equal to num, right, right, OR of 1 left shift by position. So this is what is left shifted, okay, and you OR it with bitwise, OR it with num. Then the value what you get will be, right, or the result what you see will be a bit position 1 will become 1. So let us take an example here. Example, num is equal to 4, position is equal to 1. So n is equal to 4 and the binary representation of that is 0 1 0 0. So you need to set this bit. This bit which is 0 should become 1. Now you take 1 left shift by 1 because the position is 1. So we need to left shift it by 1. So if I do that, it becomes 0 0 1 0. Now perform OR operation. Perform the OR operation. You can look at the result. What do we get here? So this will be the result. Okay. So this is how you can set the bit which is present at position 1. Right. Which is present at position 1. Okay. This is how we do it. So if you want to check with the codes and all, right, you can write a small code to test these things. stdio.h, right, int main opening bracket, int num is equal to 4 comma position is equal to 1. Okay, printf, okay, printf double quote percentage d, right, set nth bit. So pass num comma position to the function. Okay, okay, then return 0 at the end. Now you write a function int, right, set nth bit, two parameters num comma int position. So in this one, so what is the first step? We need to left shift. We need to left shift 1 by position. Now this thing, this one needs to be ORed, bitwise ORed with num. Bitwise ORed with num. And the result must be stored in num. Result must be stored in num. Once you calculate that, then return it. Then return num. Once you calculate that, you return num. Okay, and that num will be printed by this. So let us check what will be the output of this. So are we getting the output as 6? We are getting the output as 6. So it's a simple way to set any particular bit position, right? You just have to use bitwise OR operator to set a particular nth bit. Okay, so this example will help you to set a bit. Now, right, if you are working on this example, immediately after you finish, then you will get another question in your mind, how to unset or clear or reset nth bit. right? How to, right, unset. So here, right, here what you have to do is, right, what you have to do is to make any bit as 0, to make any bit as 0, right, to make any bit as 0, use AND operator with 0 at that bit position, right? For example, right, I'll write down the steps. So the step 1 is, okay, step 1 is, okay, left shift, left shift 1 by position, right, okay, right, then use, then use not operator to unset the nth bit, the nth bit, or the particular bit which you want to unset, that position bit you need to unset in this one. Then step 2, use use this value, use this value, perform bitwise and, bitwise and get the result. Okay, for example, let me show you unsetting. See, first of all, what we have to do, let's take the number as 7, let's take number as 7, okay, and you take the position as 1, okay, position as 1. Now the first step is you take the number 1, left shifted by 1 position times 1, right? Now if you do that, it becomes 0010. After that, apply not operation, apply not operation, bitwise not operation, then every bit will flip it. Now since I need to make, right, position 1 bit as 0, right, so I need to keep only that bit as 0, remaining all bit must be 1, right? So because of the property of AND gate, now you take this 7, right, binary of 7 is 0 triple 1, and perform bitwise AND it with this operation, which is 1101. When you perform this AND operation here, look at the result of this bit. This will remain as it is, this will become 0, this will remain as it is, and this will remain as it is. Now if you want to flip any bit from this to 0, right, if you want to flip that bit and you want the result as, right, 0, then use AND operator. And if you want to get the result as bit 1, doesn't matter what is present here, we don't know what is present here, I want 1 as a bit in the result, then use OR operator. But if you want the result as 0, use AND operator, right? In short, what we can say is, right, what we can say is, to set a bit, use OR; to clear a bit, use AND. So these two properties you should remember. Now if we take that, right, if we take that example here, so how we do it here, this needs to be and. I'll change the function name. I'll change the function name. Unset nth bit, and I'll unset nth bit. I'll take n is equal to 7, position is equal to 1, and here we need to perform bitwise not. Bitwise not. So if you perform this operation and return the value, it will be the result. What we have got is it is 5. So that is what we should get it here. Let's execute it and check. Are we getting the result as 5? Right. So this is the way we perform, right, unsetting the nth bit. So the position, so this is the operation. You shift the 1 by n times, that is position times, then flip all the bits and perform AND operation with the given number. So that is what will give you a result. So are you clear on how to unset and how to set a bit? Basically, these bitwise operators will do a very big job in data security, encryptions, right? Cyber security area, these bitwise operators play a very important role, right, in cyber security areas, right? That is why whenever you want to hide your data or protect your data, or anybody who gets the data should not understand them, so basically it goes into encryption. So those encryption techniques can be performed better with these bitwise operators. Okay. Now comes is, right, another one is, so we understood how to set and unset a bit. Now let's look at toggling a bit, right? Toggling a bit at nth position. Okay. So what is the meaning of toggling, right? Okay. Toggling means to turn the bit on and off, right? Means to turn a bit on and off, right? If it is 0, it should become 1. If it is 1, it should become 0. So this toggling effect is best given by an operator called as XOR. Toggling effect is always given by XOR operator because of its nature. When both the bits are same, the output is 0. When the both the bits are same, the output is 0. When the both the bits are different, the output is true. When both the bits are when both the bits are different, the output is true, right? So these are the, right, properties of XOR. So this will give you, right, okay, the toggling effect. Now let us consider an example how we can do this, right? Let us understand how we can do this. Let's take num is equal to 4. Okay, num is equal to 4 and position is equal to 1. Okay, so what is the binary of 4? Binary of 4 is given by 0100. Now I need to toggle the bit which is present at position 1. So what is the bit there? It is 0. Now I need to change it to 1. So what I will do is I'll take 1, left shifted by position. Okay, left shifted by position, right? So position is what? 1 here. The position is 1. The position is 1. Okay. Now if you left shifted by 1, then it becomes 0010. Okay, it becomes 0010. 1 0. Now you perform bitwise XOR operation. 0, right? It becomes 1, 1 and 0. Now you look at this bit. Did it change from 0 to 1? Did it change from 0 to 1? Now you take the same example, same values. Num is equal to 4 and position is equal to 2, right? So position is equal to 2. You take that as an example. So n is equal to 0 1 double 0. Now I need to flip this bit, right? This bit is currently on. I have to, right, turn it off. I have to turn it off. So how do I do it? One left shift by position, so that will become 0 1 0 0. Okay, 0 1 0 0. Then perform bitwise XOR operation. You look at the 0, the result. You can see that the bit has changed from 1 to 0. So this is the property of XOR, right? This is the property of XOR. So if you want to toggle, whenever you hear a word called as toggle, right? This is what you should get it. So 4, let's take the number as 4 and bit position as 1. So toggle bit. Now go to the function, change that toggle bit. Okay, now instead of AND operation we need to perform XOR operation, right? So according to the first example, I think some errors are there. Okay, toggle, spelling mistake, toggle bit. Okay, you can see that the result becomes 6 when I gave the input as 4 and 1. You can have a look at here. When it is 4 and 1, this will become 0. If I give 4 as a number and position as 2, entire value becomes 0, right? So let's give the position as a 2 and check whether it will work or not. Let me execute it. See, we saw that the result has become 0. Okay, we saw that the result has become 0. Are you clear on this example? Toggling a bit at a nth position. So let's go for the next example. So till now what we have done, we have, right, how to change a bit from 0 to 1, 1 to 0 we have discussed, and how to toggle a bit, right? Turning off, turning on we have seen, okay, and how to toggle a bit we have changed, right? So toggling, right, these things we have seen it. Okay, now what we have to do is, next one is, so we need to check if, right, check if nth bit is set or unset. See, please do not get confused with all the wordings. All the tasks are different. See, the first one was, right, what was the first example? The first example was to set a bit. Okay, I don't know what is the bit present there, but in the result I need a set bit. This is the first example. Second one is to, right, unset bit. Okay, means whatever is the bit at that position I don't know, but I have to make it as 0 in the result. Third one is, right, third one is to, right, toggle. Means if the bit is 0 it should become 1, if it is 1 it should become 0. So these are the three examples we have done. Now the fourth one is to check the nth bit, is it 0 or 1, that we need to find out. Is it 0 or 1? So for this one again you can use, right, again you can use, right, for this we can use right? We can use, okay, bitwise and operator, bitwise and operator. So let's see how we can do that example. Now let's say num is equal to 4 and position is equal to 1. So if number is 4, binary of 4 is 0 1 0 0. So at position right now I have a 0. Okay. Now what I will do is I'll take 1, left shifted by position. So this is what I will give, 0 1, sorry, 0 0 1 0. Now if the entire result becomes 0, if the entire becomes if the entire result becomes 0, then it is unset. Okay, then it is unset. Okay, now you check the same bit position too. Let's take a same example, right? Let's take a same example. Num is equal to 4 and position is equal to 2. So 4 is equal to 0 1 0 0. Now this bit is 1. So in the result I should get a non-zero result. So now what I will do, I'll take 1, let's shift by position, right? You need to perform AND operation. Remember that. Now 0 1 0 0. If I perform the AND operation, I will get a non-zero number. This is non-zero. Then it is set. Then it is set. Are you understanding? So 4, check nth bit. Check nth bit. Is it 0 or 1? So how to write a code for this, right? Let us write a code for this. Hash include stdio.h int main opening bracket int num is equal to 4 and position is equal to 1. Now what we will do is we'll write a function, right? Check nth bit of num comma position, right? This function will return 0 or 1. Okay, this function will return 0 or 1. If it returns 1, then printf, right, bit is set, else print it as bit is unset. Okay, bit is unset, so return 0 at the end. Okay, now we need to write this function. So check nth bit returns 1 if it is set, else returns 0, right? So int check nth bit int number comma int position. So in this one what we will do now, right? So first we need to, right, return, okay. So what operation we have to do, num bitwise and of 1 left shift by position. If you perform this operation, if the condition becomes true, then this condition becomes true. This condition will become true only if the result is non-zero. Only if the result is non-zero, then the result becomes, or that condition becomes true. If it is true, return 1, else return 0. That's how we do it. So at position 1, we know that in 4 it is 0. Let's check the result. Bit is unset. If I change the bit position as 2, the bit is set there. So you can check it here. Are you clear on that? Okay, I'll just paste that code also here for your reference. Okay. So any doubts till this point? Next. Okay. Now, right, you need to understand fifth one is multiplication. Multiply a number by 2. So we already know that it's a left shift operator. Okay, it's a left shift operator. If we shift one bit by one bit on left side, the number gets gets multiplied by 2. So it's a property of a bitwise operator. Sorry, left shift operator. So you take n is equal to 4, right, and shift it by one position, right? So yeah, n left shift by b. So 4 left shift by 1. So binary of 4 is what? 0, 1, double 0. So now you need to shift every bit by one position. If you keep on shifting like that, the result what you will get is 0. A new 0 is added, right? New 0 is added on the right side. So the result becomes 8. So whenever you are having this formula, you can use, or this operation you have to do, you can directly use a formula here, right? N multiplied by 2 to the power b. This is what you can use, right? This is what you can use to multiply a number by 2. If you want to multiply it by one time, then one bit shift. If you want to do multiply it by 2 and again multiply it by 2, shift two times. So you can use this formula, right, to multiply a number by 2. So once multiplication is done, then obviously another next question will be there in our mind as, sir, how we can do this division, right? So divide the number by 2. So obviously for this we use a right shift operator, right? So you take, right, every time we shift one bit on right side, the number becomes halved. Means it gets divided by 2. Gets divided by 2. The number gets divided by 2. You take one variable here, n is equal to 8, right, and number of bits is equal to 1. So this indicates how many bits you have to shift on the right side. So n right shift by b, 8 right shift by 1 bit. So binary of 8 is how much? 1,000. Now if I shift every bit on the right side, right, a new bit gets added here on the left side, 0, 1, 0, 0, right? So this becomes 4. So whenever you are trying to shift the bits on the right side, you can use the formula here directly, right? You can use the formula directly, n divided by 2 to the power b. N divided by 2 to the power b. So what is this b indicates? Number of bits to shift. Okay, this will indicate, right, number of, okay, next one. Okay. So next question comes is, right, seventh one. Check. Okay. Uh, 1 second. 1 second. 1 second. Okay. Okay. Now the next question is, we need to find out, right? We need to find out, okay, the rightmost set bit. We need to check position of rightmost rightmost set bit. Okay, we need to find out the position of rightmost set bit. Okay, we need to find out the position of rightmost set bit. Okay, so there are many ways are there to do this, right? You take this as a task. I'll teach you the algorithm. See, you need to learn an algorithm called as, right, Russian peasant algorithm, right? So what does this algorithm will right do? This algorithm, right, it helps to unset the rightmost bit, the rightmost set bit. It will help us to, right, unset the rightmost set bit. For example, let's take here, for example, okay, n is equal to, number is equal to, okay, let's say 10. Okay, let's take n is equal to 10. So what is the binary of 10, right? So binary representation is 1010. Now what is the rightmost set bit? It is at position 1. Okay, I want to make this bit as 0. I want to make this bit as 0. So how we can do it, right? So perform bitwise and operation, bitwise and operation of num with its previous number, its previous number. Okay, right? See here, let's, as we have taken the example here, let's take that 10. Okay, this is n. Okay, n is 10. So binary of 10 is 1010. Okay, and what is the previous number of n? It is 1 minus, sorry, n minus 1, which is 9. So binary of 9 is what? 1001. This is the binary of 9. Now perform bitwise AND operation, right? So this becomes 0, this becomes 0, this is 0, and this is 1. Now if you look at these bits, right, this was the rightmost set bit. If you look at the result, the same bit position has become 0, right? That's same bit, right, has become 0. Now where all we can use this algorithm, right? Okay, can be used to, first one, count set bits. Okay, second one is, right, second one is, sorry, One second. So the second one is right. Okay. Second one is to what was the question here? Right. Check position of rightmost set bit. Then it can be used to check number is power of 2 or not, right? There are many, see, there is no limit on, right? There is no limit on the number of applications for this algorithm. Okay, so now let's work on this example. I think probably it's time up. Okay, let us continue tomorrow.